Good morning, students. In the last class, we have discussed about the classification of amino acids. The classification of amino acids are based on the first category, position of the amino group, alpha amino acids, beta amino acids, gamma amino acid, and based on the usage of the living organism purpose, development of the activities, that is essential amino acids, non-essential. Next one is aliphatic amino acids. In that again neutral amino acids, acidic amino acids, basic amino acids, sulfur containing, and that aromatic amino acids. In that aromatic amino acids will having that. Next one is heterocyclic amino acid. These are the classification we have discussed in the last class. All amino acids are optically active except glycine. Now today we will observe that preparation of amino acids. In that preparation of amino acids, the first one is from carboxylic acids. From carboxylic acids. From carboxylic acid, the preparation of the condition. Here, from carboxylic acid condition, if you are taking any carboxylic acid, in that carboxylic acid, the minimum 2 carbon atoms are present. Then only we can discuss and we can generate the amino acid. Because of in the amino acid, the basic units are 2 carbons are present. So that is the reason we will go for 2 carbon system. I will write here generalized equation RCH2 C double bond OH. This one is carboxylic acid. Here this one is carboxylic acid. If you are observe here, this R group is changes, you will get the different type of amino acid. This one is functional group. Functional group adjacent carbon is alpha carbon. Functional group adjacent carbon is alpha carbon. Now we are using here chlorine phosphorus red. That is red phosphorus. That chlorine red phosphorus will take alpha halogenation reaction. That alpha halogenation reaction is also called Hell-Vollard-Zielinski reaction, HVZ reaction. Means if you are using this specific reagent, that will be reacted, the chlorine is reacted or chlorine is bonded at the place of alpha position. This specific reaction is also called alpha halogenation, and that reaction is identified by scientists as Hell-Vollard-Zielinski reaction. In the place of alpha position, here 2 hydrogens are there, 1 hydrogen and 2 chlorines, 1 hydrogen and 1 chlorine eliminate as minus HCl, another chlorine is bonded here. Now RCHCl C double bond OH. This one is functional group. Functional group adjacent carbon is alpha carbon. This is called alpha chlorocarboxylic acid. Alpha chlorocarboxylic acid. And this reacts with ammonia. What is the formula of ammonia? Ammonia formula is NH3. Ammonia formula is NH3. In this NH3 ammonia, here this on heating, this chlorine and this hydrogen is eliminated as HCl. This NH2 group is bonded in this position. Alkyl group CHNH2 C double bond OH. This one is alpha amino acid. Why it is called alpha amino acid? That alpha carbon amine group is present. If you changes the alkyl group, we are getting different type of amino acid. From carboxylic acid, that carboxylic acid reacts with chlorine phosphorus red to form alpha chlorocarboxylic acid and reacts with ammonia to form amino acids. If you are taking here one example, acetic acid CH3C double bond OH, it's called acetic acid. Here this functional group COOH, adjacent carbon is alpha carbon, that is reacting with chlorine in the presence of phosphorus red phosphorus. HCl is eliminated in the where it will be from alpha position. Now CH2Cl C double bond OH. This is called alpha chloroacetic acid. Alpha chloroacetic acid. This alpha chloroacetic acid reacts with ammonia. This alpha chloroacetic acid reacts with ammonia NH3. Here the Cl and this hydrogen is eliminated minus HCl to form CH2NH2 C double bond OH. This one is alpha amino acid. This is also called glycine. This is known as glycine. The amino acid name is glycine, CH10H2COH. If you are taking propanoic acid, CH3, CH2, C double bond OH. This one is alpha carbon, propanoic acid. This propanoic acid reacts with chlorine, phosphorus, red. Alpha halogenation takes place. CH3, CH, Cl, C double bond OH. This one is alpha chloro propanoic acid, alpha chloropropanoic acid, and this one reacts with ammonia, NH3. And here this chlorine and this hydrogen is eliminated, minus HCl, CH3, CH, NH2, C double bond OH. And this compound name is alanine. This compound name is alanine. Like this, if you are changing the alkyl group, like this, if you are changing this alkyl group, we are getting different type of amino acid. So this is from carboxylic acid. We also prepare the amino acids. All of you note down this. Next one. You can write any amino acid by changing the alkyl group. We are getting different type of amino acids. Next one, Strecker synthesis. Strecker synthesis. Strecker synthesis are from carbonyl compounds. From carbonyl compound. What are meant by carbonyl compound? Carbonyl compound means aldehydes and keto groups are called carbonyl compound. So here, this reaction, now I will write the generalized example here, RC double bond O R dash. In the R dash position, if hydrogen is present, it's called as aldehyde. In this R dash position, if alkyl group is present, it's called ketone. Carbonyl compound means aldehydes are, ketones are called carbonyl compounds. In the place of R dash, if hydrogen is present, in the place of R dash, if hydrogen is present, it's called aldehyde. In the place of R dash, if alkyl group is present, it's called ketone. So, C double bond O group, both sides alkyl groups are present, it's called ketones. C double bond O group, one side alkyl group, another side hydrogen is present, it's called aldehyde. So, aldehydes and ketones are called as carbonyl compounds. Aldehydes and ketones are called as carbonyl compounds. Now, these carbonyl compounds reacts with ammonium chloride and sodium cyanide. Carbonyl compounds reacts with ammonium chloride, NH4Cl plus sodium cyanide. These two are reacted and after that undergo the hydrolysis. Either acidic or basic medium to form what about the amino acids? To form amino acid R, C, NH2, R dash, C double bond OH, it will be formed. Acid group adjacent carbon alpha, this one is alpha amino acids. So, in this reaction, ammonium chloride reacts with sodium cyanide and after that generation of the product will be reacted and second step undergo the hydrolysis to form amino acid. To form amino acid, it will be formed. How this will be formed? We'll do the talk about the mechanism according to the manner. If we see here how this reaction takes place, it's called mechanism. Now first of all, ammonium chloride NH4Cl plus sodium cyanide NaCN. These two are reacts with each other. To form NaCl, sodium chloride plus ammonium cyanide. See that NaCl plus NH4CN. Ammonium cyanide will be formed. This ammonium cyanide, the generated ammonium cyanide, and further heating, it forms NH3 plus HCN, that is hydrogen cyanide. This ammonium cyanide, NH4CN, ammonium cyanide means NH4CN. On heating, it will be formed NH3. In that NH4, one hydrogen is bonded with cyanide group, it's converting as hydrogen cyanide and ammonia will be formed. Then after the formation of hydrogen cyanide, that hydrogen cyanide is reacts with carbonyl compound. Carefully observe here R C double bond or R dash, whether it's aldehyde or ketone. Carbon to oxygen double bond is present. In the double bond, one is sigma bond, another one pi bond. This pi bond energy is less. Due to that reason, the bond electrons are attracted towards this oxygen, and this oxygen get here negative charge RCO minus, and here R dash. This carbon gets what type of charge here? Plus charge. I am representing alcohol group in the downward direction. Now hydrogen cyanide is dissociated. Hydrogen cyanide is dissociated as H plus Cn minus. H plus Cn minus. First, which one is reacted? That cyanide group is reacted because of these are nucleophilic addition reactions. Carbonyl compounds participation reactions are nucleophilic addition. Why nucleophile? Because of this carbon will having the plus charge and oxygen having minus charge. Highest electronegative atom having minus charge is more stable condition, whereas this plus is unstable. So that is the reason in the hydrogen cyanide, proton is present and cyanide ion is there. Proton is present and cyanide ion is there. But this cyanide group only reacted. Why? Because here carbon plus oxygen. Oxygen is highest electronegative atom. Highest electronegative atom having negative charge is more stable. This carbon gets here positive charge. Now here first of all R C here O minus, and here alkyl group, and the cyanide is bonded here Cn cyanide, and after that proton will be bonded H plus ion because of that is nucleophilic addition reaction. Oxygen is highest electronegative atom having negative charge is more stable condition. So due to that reason that oxygen is bonded with hydrogen, alkyl group C, here OH, and another one is here alkyl group is present and cyanide. The cyanide undergo the hydrolysis. In the presence of acidic medium or in case of basic medium. In the earlier, we are taking one conversion. What is that conversion? If cyanide groups are there, the cyanide group undergo the hydrolysis, either acidic medium or basic medium. Mild condition, it's converting as amide, C double bond NH2, and further hydrolysis H2O H plus. It's converting as acid. Carefully observe, this is the conversion factor. Cyanide group undergo the hydrolysis converting as amide, and that amide undergo the hydrolysis converting as acid. Now here cyanide group is there, so that cyanide group undergo the hydrolysis, it's converting as acid, and another one is here two conditions are there. One condition is reaction with hydrogen cyanide, it will form cyanohydrin. If you write one more step here, this cyanide group and hydroxyl group, if you are writing one more step here this OH group is there, and here ammonia is liberated. This ammonia means NH3. Now this react with ammonia NH3. Here this OH group, and this hydrogen is eliminated as water molecule, and this NH2 group is added here. Alkyl group, carbon, NH2, and cyanide group, and here alkyl group is present. Now this undergo the hydrolysis H2O in the presence of acidic medium or basic medium. This cyanide group is converted as acid. Now alkyl group here, amine group, and again alkyl group. This one is C double bond OH. This is called alpha amino acid. If we changing the alkyl groups, automatically we are getting the different type of amino acids. Once again carefully observe here. Carbonyl group, aldehydes and ketones are called carbonyl compounds. These are the reagents, ammonium chloride and sodium cyanide, and after that undergo the hydrolysis to form alpha amino acid. Now this ammonium chloride and sodium cyanide reacts with each other to form NaCl and ammonium cyanide. This ammonium cyanide, on heating it, produces ammonium ion and hydrogen cyanide. The carbonyl compounds reacts with hydrogen cyanide to form cyanohydrin. to form cyanohydrin. And first of all, cyanide group only reacted because of carbonyl compounds are undergo the nucleophilic addition reaction. Why it's undergo the nucleophilic addition reaction means here carbon having plus charge, oxygen having minus charge, highest electronegative atom minus charge is stable, and this carbon valence is 4, but here only 3 bonds are present. So due to that reason, this carbon is unstable. So unstable compound first of all gets stabilized. So minus group is added. Minus group is called nucleophile, and the double bond system is there. It's called addition reaction. It's called nucleophilic addition, and after that the proton will be bonded at the highest electronegative atom. It forms cyanohydrin. After that cyanohydrin, in the reaction it will be ammonia is also there. That ammonia eliminate that H plus and OH minus, it's treated as H2O, and this amine group is substituted in the area of carbon. This amine group NH2 group is substituted at carbon area, it converting as RCNH to CN. Next cyanide conversion, cyanide group undergo the hydrolysis converting as amide, amide undergo the hydrolysis acid. If you are direct hydrolyzed the material, the cyanide group converting as acid. So this is the functional group carbon. The functional group carbon adjacent carbon is alpha, and this is alpha amino acid. If we are changing these alkyl groups, we are getting different amino acid. By changing the alkyl groups, we are getting the different type of amino acid. This is the generalized example for preparation of amino acids from carbonyl compounds. This synthesis is also called Strecker synthesis. Note down this. I think you are completed. Now we will go for another example from the Strecker synthesis. I will take here acetaldehyde. I am taking the example is acetaldehyde, CH3 C double bond OH acetaldehyde. Common name is acetaldehyde, IUPAC name is ethanol. Reacts with ammonium chloride sodium cyanide. Undergo the hydrolysis. Now CH3 here CH NH2 C double bond OH. Carefully observe CH3 CH, here OH group is eliminated, C double bond OH. How we can write the reaction? The simplified method is, here these are the two alkyl groups. In the earlier I am representing alkyl group here. This one is hydrogen. I am attached this hydrogen for this carbon CH3CH, and this is oxygen is substituted by NH2 group. This oxygen is substituted by NH2 group, and here the carbon is attached with the cyanide group and it converting as acid. So amine group and carbon. So this carbon functional group attached carbon converting as what about the acid material. So see that here how we can write that. Ammonium chloride reacts with sodium cyanide. Here we can remove the all alkyl groups. Then you can write the compound, that is your original compound is generated. Now see that here. This one is hydrogen CH3, carbon to oxygen double bond. Here CH3, hydrogen, carbon having plus charge. This CH3CH having plus charge. The cyanide group is attached here. Again here CH3, and this one is hydrogen. This H plus ion bonded here OH. Now CH3, hydrogen, cyanohydrin, then hydrogen, here CH3. This OH and ammonia eliminated, and this cyanide group undergo the hydrolysis, acidic medium, it's converting as acid. So this is CH3CHNH2COH, CH3NH2COH. That's enough. Note down this one example for preparation of amino acid. What is this amino acid? CH3CH amino acid is called alanine. Its compound name is alanine. We are prepared the amino acid is alanine. If you are prepare glycine, we are taking formaldehyde for the preparation of glycine. Like that, you can take different type of carbonyl compound, will getting the different type of amino acids. Now you may write formaldehyde, which is called formaldehyde, and this formaldehyde reacts with this reagent. What is the compound? And CH2 C double phenyl acetaldehyde. What is the compound here generation? CH3, C double bond O CH3, acetone. Write down the products. Note down those examples and write down the products accordingly. The next one is Gabriel thaliamide synthesis. First preparation from carboxylic acid, second preparation from carbonyl compounds. The next preparation is Gabriel thaliamide synthesis. Gabriel thaliamide, imide, carefully observe, thaliamide synthesis. In this Gabriel thaliamide synthesis, now I am going from the basic unit here. This one is benzene. I am taking dicarboxylic acid, C double bond OH, C double bond OH. It's called phthalic acid. It's called phthalic acid. Phthalic acid on heating, it's eliminated as OH and H minus H2O. Here it will be formed phthalic anhydride, C double bond oxygen. This one is phthalic anhydride. Anhydride means water molecule is eliminated, anhydride. This phthalic anhydride reacts with ammonia in the presence of NH3. In the presence of NH3, here this oxygen and two hydrogens are eliminated by water molecule. It form thaliamide. It form thaliamide. C double bond oxygen. Here NH. This is called thaliamide. Here nitrogen and hydrogen, which electronegativity is here nitrogen. These bond electrons are attracted. Nitrogen having minus charge, hydrogen having plus charge. This thaliamide reacts with potassium hydroxide, KOH, K plus and OH minus. This OH minus and H plus eliminate as H2O and it form potassium salt and its form C double bond. It forms potassium salt, that is phenyl ring, double bond oxygen, here double bond oxygen, En, and here N minus K plus. Here this H plus ion, OH minus ion eliminated H2O, this N minus and K plus. This is potassium salt of thaliamide. Potassium salt of thaliamide. This potassium salt of thaliamide reacts with alpha halocarboxylic acid, alpha halo RCH X C double bond OH, RCH X C double bond OH. This is called alpha halo. Why alpha? Functional group adjacent carbon is alpha. Halo means you can write down any fluoro, chloro, bromo. Generally chloro, bromo is more suitable. Alpha chloro carboxylic acid. Alpha chloro carboxylic is added. This halogen group and this potassium group is eliminated as KX, potassium salt, and here phenyl group, C double bond oxygen, carbon double bond oxygen, here nitrogen, and this halo group is eliminated, then CH alkyl group, C double bond OH, CH alkyl group. This CH group is attached here at position and alkyl CHR C double bond OH, and after that undergo the hydrolysis. 2 moles of HOH, H plus and OH minus. The bond is dissociated here. Here OH group and here hydrogens. Here OH groups and hydrogens. The bond is dissociated because of carbon and nitrogen, which electronegativity is more nitrogen. Nitrogen having minus and carbon having plus. So due to that reason, here OH groups are attached. That is again phenyl C double bond oxygen, carbon double bond oxygen, bond will be dissociated. Here OH group, here also OH, plus alkyl group R, this one is CH, and here N, these two hydrogens are bonded NH2, and this CH part is associated with C double bond OH. This is called alpha amino acid. By using what about this alpha halo carboxylic acid, we are getting different type of amino acid. In the alpha halo carboxylic acid, if you change this alkyl group, we are getting different type of amino acid. If in this place, if we are substituted hydrogen, we are getting hydrogen here, it's called glycine. In the R position, if we are substituting CH3, we are getting alanine. Secondary propyl group, valine, leucine, isoleucine, tryptophan, like this we are getting different type of amino acid by changing this. This is called Gabriel thaliamide synthesis. This one is phthalic acid. On heating, dicarboxylic acid water molecule is eliminated. Phthalic anhydride is formed, and this reaction with ammonia, thaliamide is formed by reaction with potassium hydroxide acid and base reaction. Salts will be formed. That salt react with alpha halocarbonic acid, and changing the alkyl group we are getting different type of. Now the CH group is bonded here. That CH and alkyl group COOH undergo the hydrolysis in the presence of water. The 2 moles of water is consumed because of C double bond O groups are there, and it's converting as again phthalic acid and alpha amino acid. By changing this alkyl group, we are getting different type of amino acids. All of you note down this conversion. Note, if R position hydrogen is present, it form glycine. If R position CH3 groups are formed, it's form alanine. In the X position, you may substitute any chlorine or bromine. In the X position, either you can take chlorine or bromine. I think you are completed. Then go for another reaction from DEM. diethyl melanoate, L R CH C double bond OC2H5. Here C double bond oxygen OC2H5. This is diethyl melanoate. From melanic acid we are getting this compound. This is monoalkyl DEM. Monoalkyl DEM means diethyl melanoate. This monoethyl DEM undergo the hydrolysis HOH, H plus OH minus. Here the bond will be dissociated. Here OH and H, and here OH and H. Minus 2 moles of ethanol, C2H5, OH is eliminated, C2H5OH, C2H5OH. Now alkyl group, carbon and hydrogen. Here C double bond oxygen, OH. Here also C double bond oxygen, OH. This is dicarboxylic acid is formed. This dicarboxylic acids on heating at 140 degrees centigrade. At 140 degrees centigrade, the CO2 group is eliminated, minus CO2. In this dicarboxylic acid, only one carbon having 2 acid groups are there. If you are heating the material at 140 degrees centigrade, 1 mole of carbon dioxide is eliminated. Now, alkyl group here R, C, this hydrogen, and here also this part is eliminated, CH2. This CH2, R, CH2, then C double bond OH. Again we are getting, this is carboxylic acid. This one is carboxylic, you know very well from carboxylic acid reaction, that is chlorine phosphorus red, phosphorus, HVZ reaction, alpha halogen takes place. Here eliminate as minus HCl, RCHCl, C double bond OH, and this reacts with ammonia. NH3. Here this hydrogen and this Cl is eliminated, minus HCl, and form alkyl group CH NH2 C double bond OH. This is known as alpha amino acid. By changing the R group, we are getting different type of amino acids. For changing the alkyl group, we are getting the different type of amino acids. In the R position, here R position, if hydrogen is present, it forms glycine. If R position CH3 group is present, in the R position CH3 group is present, the amino acid is alanine will be formed. In the R position CH2 phenyl ring is present, it forms phenyl ring is formed, that is phenylalanine will be formed, that forms as phenylalanine. Here it will be formed phenylalanine. Like this, different type of amino acids are preparing by changing this R group. Note down. Then another preparation for amino acids, that one is Coop's synthesis. In the Coop's synthesis, the two methods are there. From pyruvic acid, we are preparing the amino acids. From Coop's synthesis, or from pyruvic acid. We see that the pyruvic acid means CH3, C double bond oxygen, COOH. It's called pyruvic acid. In this pyruvic acid is a common name. IUPAC name, first carbon, second, third, 2-oxopropanoic acid. 2-oxopropanoic acid. And this pyruvic acid reacts with ammonia. Ammonia formula is NH3. This oxygen, these two hydrogens are eliminated by heating. Now it will be formed CH3, C double bond NH, C double bond OH. This is first carbon, second, third, 2-imino. This group is imine group, 2-imino-propanoic acid is formed. 2-imino-propanoic acid is formed and this one undergo the reduction in the presence of hydrogen or palladium, platinum, nickel. Reduction means by adding hydrogen, this pi bond is eliminated. Here NH2, here also one hydrogen, this bond is removed, addition, and here also one hydrogen, HCH, C double bond OH. This one is alpha amino acid. Again same condition, if you are CH3, CHNH2, this is alanine is the compound. Means pyruvic acid, see that carefully, pyruvic acid, CH3, C double bond or COOH reacts with ammonia, the water molecule eliminated to form this NH group is called imine group, 2-imino-propanoic acid, undergo the reduction in the presence of hydrogen, palladium. This bond is eliminated, sigma bond and pi bond, and here also one hydrogen is added, here also one hydrogen is added. So NH2 and CH, C double bond OH. Their compound name is alanine. Next reaction, it reacts with hydroxylamine. Means pyruvic acid reacts with hydroxylamine to form oxime of propanoic acid, and this react with undergo the reduction in the presence of sodium amalgam to form alanine. Next one, in the Coop synthesis, the reagent is different here. B, CH3, C double bond oxygen, COOH. This one is again pyruvic acid, reacts with hydroxylamine. Hydroxylamine means its ammonia derivative, NH2OH. This oxygen group in these T hydrogens are eliminated as minus H2O. Now it will be formed CH3, C double bond NOH and COOH. This is oxime of pyruvic acid. It's called oxime of pyruvic acid. This oxime of pyruvic acid undergo the reduction in the presence of sodium amalgam, the oxime compounds are undergo the reduction CH3, CH, NH2, COOH will be formed, and this compound name is alanine. This is also same group synthesis, but the reagent is different. Next one, pyruvic acid reacts with hydrazine and to form hydrozones, and it again reacts with sodium amalgam to form amino acids. Next, another ammonia derivative CH3, C double bond oxygen, COOH, this one is pyruvic acid, reacts with hydrazine, another ammonia derivative hydrazine, NH2, again NH2, this is called hydrazine, and this oxygen, these two hydrogens are eliminated as H2O and to form CH3, C double bond N, NH2, and COOH will be formed. This is hydrazone of pyruvic acid. This is oxime of pyruvic acid, this is hydrazone, and it undergo the reduction in the presence of sodium amalgam. It will be formed CH3, CH, NH2, COOH. That is reduction means added hydrogen is reduction, and the generated compound is alanine. These are the preparation methods of amino acid according to Coop synthesis. Why I am representing ABC means according to the ABC different reagents are there. Those different reagents are ammonia derivatives, it will be takes place. So these are the what about the preparation methods for the generation of amino acid. The last preparation method for the preparation of amino acids, that is proteins synthesis. Proteins from the proteins. Proteins undergo the hydrolysis in the presence of bases, or in case of enzymes it will be mixture of amino acids, it will be formed. That mixture will be, we can separate from the different type of chemical reaction. The proteins are having whatever the peptide bonds are present. The proteins from the proteins means the proteins will having what type of bonds are present? Peptide bonds. Those peptide bonds undergo the hydrolysis by the different type of chemical conditions. What are the chemical condition means? Either basic medium, or in case of enzymatic reaction, that is called biocatalytic condition. It will be produces mixture of amino acids, means protein chain is huge chain, it will be there. In the protein chain it will be dissociated. By the dissociation we are getting mixture of amino acids, we are getting that mixture. We are using different type of separation technique, we can separate the amino acids. So these are the preparation methods for amino acids, and those after the preparation method will go for the properties. The all amino acids are the water soluble, it will be natures are present, and all amino acids are having colorless crystalline form, it will be there. And these are amino acids will having that, if we carefully observe the properties of amino acid, water soluble nature, crystalline nature, it will be there. You can take any amino acid, the amine group and acid group both are present, amine group, acid group both are present. So due to that reason it takes place the reaction, acidic reaction, basic reaction, and neutralizer reactions is also takes place. And amino acids is a organic nature, it will be there, and amino acids will having the highest electronegative atom of nitrogen and oxygens are there. So it's soluble in the water due to the hydrogen bond, and less soluble in organic solvent, more soluble in polar solvents like water. Why more soluble nature means due to the hydrogen bond nature, it will be more soluble nature is there, except glycine. Remaining all amino acids are optically active, and it shows what about this acidic nature and basic nature, and one special character it will be there, that zwitterion nature it will be takes place, and highest melting points and boiling points is also takes place. And these all amino acids will react with either acidic medium and as well as basic medium to show the different type of organic reaction. The application reactions will discuss in the next class, and all the properties and chemical properties and zwitterion characters will discuss in the next class.